Thank you, Dan and Nicolo. So tonight, a lot of the talks, presentations here are about delivering video to the end user. But before, you have to have video to deliver to begin with. And so what I'm presenting here is about actually producing video to be delivered. In this case, it's about producing live sports events, which are usually a challenge for producing, and everything has to happen in real time. But this is a system that uses the SMPTE SD2110 standards entirely. There's no SDI used in the system. I'll do a quick overview of the 2110 standards that are used, and this is not a 2110 tutorial. If you want such a thing, there's presentations online that are much better than anything I could do, so I can direct you to some of those tutorials. I've seen good tutorials and bad tutorials online, so just talk to me and I'll try to help you out there. The interesting thing about this is it's a hybrid system. It has components on the ground or on the premise, and components in the cloud. I'll show an overview of the system showing the data flow. This is primarily focused on the data flow, and the system control is not shown in any kind of detail here. And then there'll be more, I'll break down the discussion into more details about how the 2110 capabilities are used by the equipment. And to finish up, we'll talk about the advantages of using 2110 versus SDI for live production. And last of all, what I'm presenting is nothing new. It's not breaking news. I'm showing a real system that's been in use for a couple of years, and it's on air today. So this is a summary of the standards used, including the 2110 standards and other standards that are necessary to do a 2110 system. And for the 2110 suite of standards, the 2110-10 kind of gives an overview of the RTP packet structure and system timing. The important thing is this is based on RTP packets. 2110-20 explains how to, the case of where the payload is uncompressed video in the RTP packets. 2110-21 is also part of the video, and it specifies the packet timing and the traffic shaping to make sure everybody has fair access to the network and buffers don't overflow or underflow. 2110-30 is PCM audio, and I didn't put it here, but it's based on AES 67 standard, so it's just a few little tweaks on that standard. 2110-40 carries ancillary data, and the 22-7 is an older standard. It's been around for some time, but it has been enhanced to include support 2110. It's the purpose of it is for redundancy, and it uses seamless reconstruction, which means the reconstruction on the receiving end is happening on a packet-by-packet basis. And I make a kind of a point of that because a lot of people think, oh, it's a failover kind of system, but it's not. It's on a per packet basis. One leg or the other leg of the network can be used for each packet that is coming into the receiver. And finally, we need reference timing for this system, and that is SMPTE 2059 suite of standards. It is based on the IEEE 1588 PTV standard, and there's some enhancements and constraints for broadcast video. An example of that would be to insert, to carry, or I should say calculate PTP or SMPTE time code from PTP. Some details. The name of each standard begins with professional media over managed IP networks. I highlight managed because that is a very key thing, is you have to have you have to scale the system such that it can carry all of the data. And since this is a multicast kind of situation, if there's any kind of congestion at all, packets will be dropped and you'll have problems. Another thing is the media essence and the PTP reference are all on the same network. A single cable carries everything. One of the 2110 points is that you can use COTS networks switches, something like an Arista or a Cisco switch. But the thing that happens is these switches will not work out of the box. And that's because they're configured as data center switches. So they must be configured for several things. I give a few examples here. One is for the non-blocking IP multicast, and also flow control is disabled, and PTP must be enabled, and usually it'll be configured to compensate for network delays and jitter using PTP boundary clocks. In this system, just to calibrate, it's the video's 1080p at 59.94 hertz, which the video bit rate is about 2.6 gigabits uncompressed. This is a diagram, kind of an overview diagram of what I'm going to describe here, and there are basically three different distinct locations. First of all, you've got the remote venue, the remote stadium that the event is happening at. Then you have a central production center that is actually does the video production. It's the production facility here. And finally, the cloud is used for a couple different services. We'll go into more details on this. So now you look at this, and I say that 2110 has very strict timing requirements. So how is this timing all locked together when you're at all these different sites? The PTP there has to be PTP grandmasters at each site. Typically, you have 2 or more grandmasters for redundancy purposes, and the grandmasters are locked to GPS signals. So PTP time at each site should be very close. On the previous diagram, I didn't call out PTP, but it is distributed on the 2110 media network, and just assumed to be there, available for all of the devices on those networks. Now let's look at the first step, and that's where you have a remote stadium venue that has a number of cameras and microphone feeds. And those feeds have to be moved to the central production center. What is used is media gateways, which moves them over the long haul connections from the venue to the central facility. And so you might be going 1,000 miles or more on these long haul connections. Since 2110 packets are based on RTP, that means that they pass through these standard media gateways just fine. And once on the production center network, the individual video, audio, and ancillary data streams can be used by individual components on the network. Now, my old employer, Harmonic, I'll talk about a couple of products of theirs that are involved in this scenario. First of all is the Harmonic Spectrum. It is a playout server, but it also supports live feeds, live inputs coming in. So the one role of this server is that it is preloaded with commercials that will play out during the game. So, and I'm not proud of that. I've developed a product to play those commercials for you, but that's one thing it does. So the live input joins the game feed from the stadium, and then upon the control system, the automation system, will insert commercials. In other words, switch from a live input and play an ad, or more than one ad, and then after the ad break is done, it will switch back to the live feed. Another role of the spectrum here is to deal with the closed captioning, and so we saw that coming from the media gateway, there is 211030, which is the audio stream. Now, that audio stream can go to multiple locations, and one thing that it can do is go up to a service in the cloud. This is provided by, the service is provided by yet another vendor. And that service does speech recognition and then generates the caption data. This caption data gets encapsulated in a 2110-40 stream and then comes back down to the production center. So again, this is easy to do. Each of these streams is separate, so there's no special video equipment or anything needed to split audio from video and so forth. It's just a matter of directing the streams to the right location. And when the 2110-40 stream comes back to the spectrum, it gets multiplexed in with other 2110-40 streams with other ancillary data. Again, no special equipment required. It's just a matter of a little bit of software to do this. So the output of the spectrum is the completed program stream. It includes the live action from the cameras and the commercials inserted at the ad breaks. Up to this point, it's been all uncompressed video and audio, which helps maintain high quality until the final encoding step. The Harmonic XOS is an encoder that can encode to various stream formats. In this case, it's configured to produce HLS. The encoder channel has to be configured according to whatever the desired stream parameters, including such things as the compression format and the bit rate and so forth. And even in this case, you might have multiple encoder channels that could be receiving the same input and then encoding for different purposes, if you will. Finally, the encoder output is sent to a CDN in the cloud, and from there it gets delivered to the various devices that subscribe to the game. It could be a TV, it could be a cell phone, whatever is out there. And that part, the part of the CDN and beyond, I know there's people in this room that know a whole lot more about that, so that's all I'm going to say about it. So let's talk about the advantages of this kind of system. The traditional SDI-based systems required one or more large trucks of specialized video equipment to be at each venue. And the equipment had to be transported, had to be configured and set up. And now with this kind of system, the amount of equipment that has to be at the venue is reduced by quite a bit. Obviously, you need the camera equipment and you need a reliable network bandwidth to the production center. Again, the video and audio remain uncompressed until the final encoding step, again to maintain high quality and keep the until that encoding step. The equipment at the production center can be shared between events, and so we've got this expensive equipment that's there, but it's used across multiple events, and so that reduces the cost per event significantly. And what happens, the equipment can be reconfigured for each event. For example, they might download different commercials or regional commercials and so forth, depending on where the event is directed. And another advantage is with SDI, you have to have large bundles of SDI cables. And in this case, all feeds are actually on one or two fiber optic cables. And usually it'll be two cables just for 2022.7 reliability. Another advantage is that no special video equipment is required to separate audio or ancillary data. All the streams are routed by multicast IP address and port number. Multiple 2110 inputs can receive the same stream. It should be the same type of stream. In this case, the example I gave, it was a 2110-40 stream. There's two streams coming in, and it could be more. So there's no need to have some special video equipment that can do that multiplexing. And so on a single channel, multiple 2110 input streams can be combined and presented on the output. So now I'll take questions. Mike.
All right, I'm going to start with the first question here today, and then we'll go over to Mike. And who's here is familiar with Big Brother, the show? Anyone ever heard of that? So for the last 28 years or 25 years at this point, it's been going on for a while since I was younger. We've had a truck out in front, and it costs a lot of money. This is the first year we're doing full 2110 attribution, everything inside the house without the truck. So this is a big thing for us. This is why this talk was tonight's very interesting. I did not know about this subject until before tonight. I'm sorry, I'm not talking into the mic. We have a sound problem here because of the feedback on the speakers that sit behind the mic. Not much we can do about that, but I will try to talk in the mic. And Andy, when you get up, bring the mic close. All right. So anyways, it's really interesting, and that's really what you were talking about, right? There's no need for the truck. You have a simpler flow. We have, 38 cameras in the house. They're all going to be connected with a much simpler inputs, I guess. I'm wondering, actually. That's really where the base of my question would be. Am I pretty much on target with the cost reduction in this workflow?
Yes, I think you are. I mean, it's like you have the cameras, and each camera is outputting 2110. So, and each one of those 2110 streams uses a specific multicast IP address and port number. So each one is unique in that respect. So, and then at the receiving end, you can just pick which feed you want, or if you want multiple feeds, certainly you can do that too. You might, be doing a DVE squeeze back or something and run it into that kind of window. So yes, that's exactly. Yeah, okay.
It's
Yeah.
I want to focus on the part that was sending the audio up to the cloud and getting metadata back. And to me, it feels a little gold-plated or something. Like, why use 2110 for that purpose? To me, like, you use 2110 if you want, like, the lowest latency and synchronized. And in this case, well, and also, I mean, when you're sending to the cloud, you've got to think about, like, resiliency of the connection and all that kind of stuff. And to me, the audio is low enough bit rate where you could send it some other way that might be way more resilient. And of course, the metadata, same thing. So I guess I'm curious why 2110 was used for that part of the application.
I was not the decision maker at this this customer, and the system integrator decided to do it that way. I think part of it too is they can buy these services to do the automated closed captioning, so they could change vendors by doing this way. And so in this case, I think it's probably the way the vendor, they're buying the service from a vendor, and that's how it is specified.
I think that's funny because, like, when I was at AWS, we had customers saying, we want to do 2110 in the cloud, and we were busy telling them, no, you can't do that. And so, and now you're showing me this thing that has 2110 in the cloud and saying that this is like a normal customer type product. And so, I guess in the cloud you have these problems where you don't have control over timing very well, and there's no real multicast or anything. So I guess I'm a little surprised that there's like easily purchasable commercial products that can do that, but whatever.
Yeah. Well, and like I say, I'm not privy to exactly how that worked. Unfortunately, I would like to know more about it, but I don't.
All right, try to keep the mic.
Yeah, I think I can answer your last question. Like, I used to be at Amazon as well. So, when cloud comes in, these are on-prem private clouds that certain vendors operate. It's just that they don't force you to buy the equipment. You just ship it to somewhere. Like, cloud is somebody else's computer, right? That for old timers, that's what we learned. So, but that was actually going to be a related question. There is, why multicast? Because if it was not multicast, then it could be sent to a real cloud with all the resiliency and everything. And multicast is useful when you have one to many. This is from many to one, and effectively unicast could do the same job today because bandwidth is not constrained. When it was a 100 meg circuit Ethernet, then it was a problem with bandwidth. Today, I haven't seen a 10 gig circuit or 1 gig circuit in such a long time in any real network that 2.6 gig is just fine. You can send 5 of those or hundreds of those, like what? Not hundreds, but close to 40 of those in a 100 gig circuit, which is the standard normal way in which commercial networks are created today. Right, so just curiosity, why, if that was a legacy of using multicast or?
Well, first of all, you said that the one-to-many thing. Now, you noticed on the diagram, the audio, 2110-30, was going into the server, right? But it was also going to the cloud simultaneously. So it is one-to-many. Well, 1 to 2 at least. Yeah. So that's why, and typically 2110 systems are multicast, so that multiple devices on the network can receive the same feed. It's kind of like what I mentioned, like if you had, say, 2 encoding channels, they could be receiving the same feed, but encoding to 2 different formats, if you will. So, in other words, if I had 2 encoder channels, could receive the same feed and encode them for 2 different directions, 2 different compressions, and so forth. Right?
I can I can answer the multicast question a little bit. So I worked with a company who was using multicast for SMPTE 2110. And they did that from a management point of view. They could manage what could connect to what in a central way by just controlling the multicast groups. And so they used multicast groups as a basis of all their video routing. And then they didn't have to set up discrete negotiations, like point-to-point negotiations between. So something would produce video, and it would multicast it out, and then whatever needed to hear that video was controlled in a central way by manipulating the multicast groups. And so by just always using multicast, anything that they wanted to receive it could receive that video signal, and they programmed that in a central way. And then they're using NMOS for discovery and all that. So that's why multicast is useful for a SMPTE 2110 workflow, and that's useful in a facility. So like a truck or in a data center facility. It's not useful so much for contribution over the internet or over fiber. My question was, though, and I don't know if this is Dan for you, but for the 2022-7 redundancy, so is that being sent over totally separate circuits then also?
Yes, it is. Normally that would be like 2 different subnets or 2 different networks. Yes, yes. So the equipment that the 2 different legs of the stream is going through separate network equipment, separate cables, whatever the failure points. It's all redundant.
Okay, I was going to ask because the same company was using 2022-7 within the facility for redundancy, but I hadn't seen that used like for contribution, like on fiber circuits from origin. So that's kind of interesting. Yeah, that's pretty high bandwidth, but private fiber.
Sure.
Like,
yeah.
Yeah.
And
I'll take the 22.7 follow on. This is how we do it. So I ran, I've left Microsoft, but my last year at Microsoft, I did the NBA Summer League using a similar setup where we replaced an outside broadcast truck with effectively 9 servers sitting in a rack. We had 2 people running the production on site. I was one of them, so really we only had 1 person. My job was to make sure it stayed plugged in and nobody unplugged it, and that there was Ethernet connected to it. Beyond that, the production team sat in Canada as part of Evertz. We were running the Evertz system on it, and then we were using a TIM encoders to package up. We were doing 2110 all the way to the cloud initially. The reality was that, and we could do it for bandwidth, but there were so many firewalls in the HSAN network that NBA runs that we found better for us to flip it to JPEG XS and then send that to it, because we were greatly reducing the bandwidth constraints that we were doing on it. But technically the 2110 worked. The hitless merge, or the 22.7, so we were using, primary leg was HSAN, so fiber all the way back to Secaucus, New Jersey, to their facility, where it was then dropping into an Azure network, because this was all running on Microsoft Azure. But then we were using just public internet to send the 22.7 side, and it worked. So we used completely unmanaged network on that side, and we're able to pull it off. And it looked great, and basically proved it out, and it's what NBA was starting to build flight kits around so that they could extend out the European leagues and the Middle East games and other pieces that they were doing. Oh God, it's like 1.5 years now, so I'd have to go back and double check. But we were in millisecond range. I mean, we were doing good on latency. We were keeping up with the broadcast system that they were running, because I don't know anybody who's ever watched. Summer League is effectively just a giant sandbox where they're running a full production team from ESPN, but then they bring in a bunch of vendors and do a bunch of tests behind the scenes. So we just took all of their channels. We were running 12 channels, I think, of program into the cloud for vision mixing and then final delivery out. And we were within a couple milliseconds of matching what they were putting out production-wise.
Yeah, I'd like to address, first of all, to do we're talking about bit rates, and the audio bit rate's 1% of what video is. So I mean, it's a low bit rate relatively. So and the whole thing, speaking of NBA, I was watching an NBA game a while back with the captioning turned on, and it's one of these cases where you see the caption, you see the game, and they switch to a commercial, and the captioning just is a mess, in my opinion. It's like FCC requires them to have captioning, but doesn't necessarily have to look good or something. I'm not sure what the rules are there, and so they're not doing it cleanly, right? When they're switching between the live microphones and so forth, and the commercial. So yeah, so it's and of course the captioning too. You can see the delays. I mean, the captions are way behind the speech.
Any other questions for Harold? All right, let's put our hands together. Thank you so much, sir.